Hi there, and welcome to Ian's Engage channel. I'm Ian. In the previous video in the Tricky Bit series, I'd encountered a problem with getting the servo motor wiring below the layout. This was because the holes that were required were too close to the baseboard framing below the layout. I'd ended the video by showing a list of things that needed to be done to complete the first section of the Tricky Bit, and top of the list was drilling holes for the servo wiring. However, there was another problem to solve that wasn't on the list, and that was to replace the servo enclosure boxes to allow servo motors to be removed that would otherwise be trapped under their point rodding. So this task had now been added to the list. The good news was that in my previous video I'd already redesigned the enclosure boxes and had built some ready for installation. So in this video I'm going to show how I've tackled the top two items on the list. I thought I'd found a pretty good solution for getting the servo motor wires below the layout. The method I was going to use also had the added advantage of being able to route the wiring away from the baseboard framework. The plan was to create a channel in the bottom layer of foam that the servo motor wiring could run through. The channel would extend far enough away from the back wall to allow holes to be drilled away from the baseboard framework and allow me to position my drill more accurately. This method would allow me to drill big enough holes to get both the servo motor wire and the Fataba connectors below the layout. I started off by marking out where I wanted the channel to run. Next, I set about removing the foam using a chisel and eventually my utility knife. I then marked locations for the servo motor wire holes. Eventually, I was left with the plywood baseboard at the bottom of the channel along with some glue and foam remnants. I then used a 6mm drill bit to drill holes at the marked locations. The final step was to use a 12mm drill bit to make holes that would be wide enough for the servo motor connectors to fit through. I was now happy that all of my servo motor wiring would be able to get below the layout, so the next step was to install new servo enclosure boxes. In my previous video, I showed how I'd redesigned the servo enclosure boxes so that the servo motor could be removed even if it had been trapped below its point rodding. Since that video, I'd moved the design on a little further by making 3 modifications. I'd increased the depth of the recesses in the sides of the box where the point rodding will run. I'd resized the tabs on the end of the box so that the sides would only fit in one way up, which would reduce the likelihood of fitting them the wrong way around. And I'd also reduce the height of the removable T-piece so that it would no longer touch the bottom of the box in an attempt to prevent it from getting stuck when ballasting, although I'd probably ballast with the servo motors removed, just to be on the safe side. Anyway, in this section of the tricky bit, 2 of the 3 enclosure boxes needed to be replaced. I used my utility knife to slice behind the Greyboard walls of the enclosure boxes in question, being careful not to dig too far into the foam. I worked my way carefully around the box until I'd completely severed the PVA bond. For one of the enclosure boxes, I needed to remove one of the points, and the point rodding for better access. Eventually, both enclosure boxes were separated from the foam. As the new enclosure boxes were about 15mm wider than the old ones, I then needed to widen the apertures they fit into. I used my utility knife again, along with a metal engineer's square to mark and cut away the foam, and some of the Cork road bed. Once that was done, I used a good quality PVA glue to stick the new enclosure boxes to the foam. It was important to get the enclosure boxes the right way around, and to butt them up to the same edge as the original boxes. Where there were small gaps between the side of the enclosure box and the foam, I used Greyboard to fill them in. I've also removed the Greyboard I was using to raise the point rodding, as the recess in the side of the enclosure box now negates the need for it. Talking about recesses, I've also cut a small notch into the side of the original enclosure box that will allow point rodding to pass through it. The final step of the installation will be to spread superglue along the edges of the enclosure boxes and the T-piece to prevent the Greyboard from fraying, and which will also make them stronger. Unfortunately, I can't find my superglue at the moment, so that will have to wait. Okay, so that's about it for this update. Yes, progress has been slow, but it's not at a standstill yet, so at least that's a positive. Coming up with the design for the servo enclosure boxes has been pivotal in allowing me to build the layout on XPS Foam, so I've spent lots of time getting the design as good as possible. I'm sure this will pay dividends eventually, especially as I begin to install them in the scenic sections of the layout. There's still a lot of things to do on this section, but at least the list is getting shorter, and what's left to do is pretty standard stuff that I can hopefully get on with more quickly than my usual snail's pace. Anyway, let me know what you think. Was digging a channel into the lower level of foam a good idea? If not, how would you have avoided having to drill through the baseboard framework? Alternatively, If you've got any hints, tips, useful tools or techniques to pass on to a beginner in N-gauge modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress soon. Bye.